So Gibson here. We're going to take a look at our first lesson in this new unit on data analysis and statistics. And we're going to do a little review of what the measures are of center. We call them measures of center. What different ways do we have to describe the values that best represent a set of data? And then also something called the standard deviation. So let's look at our objectives. So the first ones are to be able to find these three measures of center. The measures are the mean, the median, and the mode of the data set. And then once we find those, we're going to determine which measure of center best represents the data. In the second half of the lesson, we'll go through the process or procedure to find the standard deviation of the data set and interpret what does this standard deviation value actually tell us. All right, so mean, median, and mode are three different measures of center of a set of data. Now, when we say measure of center, we're trying to say, okay, for a given set of numbers or values, we have different ways to describe a value that best represents the data. So let's define each of these. The first is the mean. The mean is the arithmetic mean or average of the data. So we've done this before. We actually did this back in our lesson on sequences and series, right, where we use the arithmetic mean or simple average to find a missing term. Here, we're going to do the same thing, find the mean by dividing the sum of all data values by the number of values. And we'll go through an example here in a minute. But I think you know how to find an average, right, of a set of numbers. The median is the middle number in a data set. And we find this by listing the values in ascending order and select the middle number. So we list the values from their smallest to their largest values, and then we count and find the value that is in the middle. In other words, we have the same number of values before and after the median value. And then the mode is actually quite simple. It's the number that appears the most often in the data set. All right, let's take a data set here: 4, 11, 16, 8, 9, 40, 4, 12, 13, 5, and 10. And let's find the median, mean, and mode of these sets of values. And then after we do that, we're going to ask ourselves which of these measures, and it could be more than one, best represent the data set. So let's do the mean. So remember, the mean is simply adding up all these numbers and then dividing by the number of values. So we just add up all these numbers. We don't have to add them up in any particular order. We can just take them in the order that they're given to us and then count, right? How many values did we have? And if we count these up, we see that we have 11 values. So if we add all these up carefully on our calculator, we get 132, divide that by 11, and we get a mean or an arithmetic average of 12. So on average, these values equal 12. All right, let's find the median now. Now the median, we do need to rearrange the numbers in ascending order. So we go, in this case, from the lowest value of 4 to the highest value of 40. And then we count. Since we have 11 values here, we want to find the sixth value, right? The sixth one in the sequence or list here, because that would have 5 values before it and 5 values after it. So that turns out to be the value of 10. So we would say the median here is 10. And the mode, it's actually helpful to use the same list in ascending order and just look and see which values appear the most often or most frequently. And here we can see that there's really just one value, 4, that appears twice. So we would say this set of values has a mode of 4. Okay, so let's summarize those, right? Our mean, and notice the symbol we're going to use for mean is an X with a bar over it. Anytime you see a bar like that over a variable, it implies the average or mean. Okay, so X bar equals 12, or the mean. The median, we don't have a symbol for that. We're just going to write it out. The median equals 10, and the mode equals 4. Now, the second part of that question is, which measure of center best represents the data? Is it the mean, the median, or the mode? So one thing that can help us answer that question is to visualize our data. So what I've done is put the data on a number line here, okay? And each blue dot represents a value in our data set. So notice 4, right, which is the least value, appears twice. So we actually have 2 blue dots at 4 on the number line. 5 appears once, so we put a 5 there, and so on, right? You can see we've got the values of 8, 9, 10, 11, 12, 13, and then 16, and then we've got 40 at the far right here, okay? And that starts to give us kind of a visual picture of how the data values are distributed, okay, across a range of values. So let's indicate, right, where the mean is. So the mean we came up with was 12, the arithmetic average. So that would be that dot right above the red arrow. The median was 10, and the mode, right, was 4, way off to the left. So in looking at those 3 values, mean, median, and mode, which ones best represent the data, or the center of the values of the data? And in this case, it would be the median, right? And in this case, by definition, the median is has equal number of values less than it and equal number of values greater than it. So we would say the median best represents the center of the data. Now the others, the mode here is 4. That's not a very good representation, right? Because it's less than most of the values in our data set. Right? It's actually the least value of all the values that we have. And the mean is greater than most of the data set, right? The mean is 12. There's only 3 other values that are greater than 12, but there are, let's see, 7 values that are less than 12. So in this example, this won't always be the case. In this example, the median best represents the center of the data. Okay, so there's an example of how to find the mean, the median, and the mode, and then answer the question, which measure of center, which of those 3 do you think best represents the data and why? All right, let's move on to the second part of our lesson here. Oops, actually, before we do that, let's talk about a couple special cases of median and mode, because these may come up, or you might have already had these questions in your mind. So what is the median if there are an even number of values? Remember, we're trying to pick the center value, but if there's an even number, then we won't have a number that has the same number of values less than and the same number of values greater than. So how do we do that? We use the average of the 2 numbers that are in the middle. Let's look at an example here. So I've taken basically the same sequence that we had, but I dropped off the 40. So now we're down to 10 terms, right? So if we have an even number, we're going to identify the 2 numbers that are in the center. So in this case, 9 and 10. And then we're going to simply take the average of those 2 numbers. So the median in this case would be equal to 9.5. Okay, so that's how we deal with it if we have an even number of values in our data set. All right, now how about for mode? What if there are multiple numbers that occur more than others? Right, in that first example we did, it was just the value of 4 that appeared twice. If that's the case, we have more than one, then all of those numbers that appear most frequently are modes. So let's look at an example here. Okay, we'll use the same data set that we started with. This time I added an extra 13. So we see we still have a mode at 4. Now we also have a mode at 13. So you can have more than one mode. Okay, in this case, we have 2, one at 4 and one at 13. Now, you might ask the question, what if there are no numbers that occur more than others? In other words, each value is unique and only occurs once in the data set. Then we would simply say there are no modes, or there are no values that are modes in our data set. Okay, so a couple special cases there for how we find the median or the mode of a data set. All right, now let's talk about standard deviation. So let's define it. And this definition won't make a lot of sense when I first put it up here, but we'll go through an example and then that'll start to make sense. So the standard deviation, this is kind of the big idea, is a measure of how much the values of a data set are spread out. So the greater the standard deviation, the greater the spread of the numbers in our data set. Now, mathematically, what does it mean to find that? The standard deviation is the square root of something called the variance. So what is the variance? The variance is the average of the square differences from the mean. Now that is a mouthful there. So let's go through an example of calculating the standard deviation of a data set, and this definition will make a little more sense. Okay, so here's our data set: 10, 2, 6, 8, 12, 15, 18, and 25. Let's see, I think we have 8 values there. Okay, so here are the steps to find the standard deviation. The first, we already know how to do this. We just did this a few minutes ago. Find the mean, okay, or the arithmetic average. So if we add all these values up, we would get 96. We have 8 values, so we're going to divide by 8, and we get an average of 12. Okay, so our mean is 12. The second step is to find the deviation of each value. And by deviation, we mean how different is it? What is the mathematical difference between the value and the mean that we just found? Okay, now these steps are going to get a little complicated here. So as we work through to calculate the standard deviation, it's very helpful to organize it in a table here. So notice the table has 4 columns in it. The first is X. That's just the data values in our data set. The second column is the mean. And so notice it's the same for all, right? Because the mean of all of our values in the data set is 12. Okay, so we've already filled that in. The next column, though, is this deviation. And the deviation is where we're going to subtract the mean from the actual value. So 10 minus 12, we're going to put that in this column here, would be -2. 2 minus 12 is -10, and so on, right? We get down to the bottom, we have 25 minus 12, we get 13. So the deviation is you can think of it as the distance, right, that the actual value is from the mean or the average. All right, so that's step 2. Step 3, we're now going to take each of those deviation values and square it. Okay, so you know how to square a number. -2 squared, right, gives us +4, and etc. We can fill in the rest of these values here. Notice we'll always get the positive values in this 4th column, because if you square a number, it doesn't matter whether it's positive or negative, you're always going to wind up with a positive result. All right, that's step 3. Step 4 says to find the mean, so that's our arithmetic average of the squared deviations. So find the mean of the values in this 4th column here. So all of these numbers here, right, we want to add them up and then divide by the number of values, 8, and we get this value of 46.25. Now, when you work through examples, It's very likely you'll get decimal values. You can just simply round them off to 2 places. That will be plenty of precision for us here. All right, last step now is to take the square root of the mean of the squared deviations. So take the result we just had, right, 46.25, and take the square root of it, and we get approximately 6.80. Again, we can just round this off to 2 decimal places. Now notice I've used this Greek letter here. It's called sigma, and sigma is the symbol or variable that we're going to use to represent standard deviation. So if you start to see that on some of the problems, or that's information that you're given, that sigma means it's the standard deviation value that you're being given. Okay, so we found our standard deviation, 6.8. So what does that actually tell us? Okay, so that's kind of the next question here we want to answer. What does the standard deviation tell you about the data set? And for now, the way we can answer this, it says the typical data value differs from the mean by about 6.8 units, okay? So in this case, it's something we call the geometric mean, right? We square and then take the square root. Actually, it's called the root mean square. But it tells us that typically the values are about 6.8 units away from the mean of 12. Okay, so you could say, okay, kind of on average, the values are going to be either 6.8 units above 12 or 6.8 units below 12. Okay, that would be how we would think of the standard deviation. Okay, so that's it. That's it for this lesson. I just want you guys to get comfortable with finding the mean, the median, and the mode of the data set, and then determine which measure of center best represents the data, give your reasons for that, and then to go through the process of finding the standard deviation and interpreting it, right? What does that value actually represent or mean? What does it tell us about our data set? Okay, that's it. Thanks. Take a look at the assignment.